So the theme of today is constructive algorithms. How many of you are hearing about this category of algorithms for the first time here? Okay, this is a really interesting category of problems and algorithms, whatever you want to say that. And let's first understand the basics of it. Okay, let's get the basics right, and then it will automatically make a lot of sense. Okay, what is the meaning of constructive? Constructive means to construct something, as simple as that. So constructive algorithm is basically it's a class of algorithms which doesn't just check the existence of solution, rather generates one such solution. Okay, so I'll probably give you an example and it will start making a lot of sense. So let us say you have a graph. So this is some graph that you have got. Let's say this is a graph and your nodes are A, B, C, D, E, F, and G. These are the nodes. Now you have been asked a question. Your question is so you might be given a question. That question could be, hey, check if there is a path from A to G. I mean, is there a path from A to G? So what would you say? In this particular graph, do you see a path that goes from A to G? You can clearly see that, right? You can go like this and then this, and that way you will be able to reach from A all the way till G. So you would say yes. The answer is yes, there is a path from A to G. But then there can be some questions which would say that, hey, I'm not just interested in yes or no, I'm interested in printing one such path. See, there could have been multiple paths that goes from A to G. I mean, if our graph could have been something like this, let's say there is a node Y. In this case, this is one path that goes from A to G, and this is yet another path which goes from A to G. So the question could be that print one such path. So you could have printed A, Y, G, and you could also have printed A, C, E, and G, right? So this is where any problem exhibits the property of constructive algorithm that, hey, we are not just interested in yes or no, whether a solution exists or does not exist. Rather, we are interested in printing one of the many solutions. So now this also points to the fact that if a problem belongs to the class of constructive algorithms, then most likely there will be multiple solutions. And yes, there are multiple solutions. Each solution, so let's say there is a solution S1, solution S2, solution S3, and each solution can be crafted by using a particular approach. So let's say approach 1 crafts solution 1, approach 2 crafts solution 2, approach 3 crafts solution 3. And you have to somehow come up with any of these approaches. If you are able to pick this approach, you will be able to generate this solution. And usually such questions say that if multiple solutions exist, print any one solution and your code will be accepted. I'm sure you would have read lines like these in some questions. Have you read? The last line of a lot of questions say that if multiple solutions exist, print one such solution, right? Okay, so let's take a very simple example. I mean, a really, really simple example of constructive algorithms. So see, the key word over here is constructive, to construct. You have to construct something. Now, there could be multiple ways to construct, right? Each way would lead to different result, but as long as that result is proper, you can print it, you can return it, and that will get accepted. So let's start with a very simple question. Let's say somebody says that you might have read, problem statements like these on code forces that let's say there is a boy called as Aman who is fond of arrays, okay? And he is especially fond of arrays in which the adjacent elements differ by no more than k. Now it's Aman's birthday and you want to gift him one such array. So you want to gift him one such array of size n in which the adjacent elements differ by no more than k. So let's say the value of k is 4. Then an array like this 1, 5, 9, 5, 1, 5. This is correct. Because here, if you pick any pair of adjacent elements, let's say you pick 1 and 5, their difference is 4. I mean, the absolute difference is 4. 5 minus 1 is 4. Similarly, this thing, absolute difference is again 4. Here, the absolute difference is again 4. Here, the absolute difference is again 4. Here also it is 4. So you can clearly see in this question, can I have multiple solutions to this question? Can I have multiple arrays which exhibits this property? Yes or no? Of course I can have. For sure I can have, right? This is one such array and somebody could have said that, hey, I can generate an array which is like 0, 4, 8, 12, 16, 20. This is also all right? Because you can see that every adjacent pair has a difference of no more than 4. In fact, it is exactly 4, right? The difference could also have been smaller than 4 because it is saying no more than k. So the difference could also have been maybe 3. So instead of 20, I could have had 19, right? Now, if I ask you to write a code for this, there can be multiple ways to write code for this, and those different ways would generate different solutions, and all of those solutions would be correct. So probably if somebody is asked this question, that person would say that, hey, the simplest way is let's initialize an array. Let's put the first element as 0 and the next element as 0 plus k, and then next element as k plus k, the next element as this plus k, and so on, and simply return this array and your job is done, right? It's as simple as that. And then some other person could have come up with some other solution. Somebody could have said that, hey, let's initialize our array with a very large number, let's say 1000. And then the next number should be this minus k, which is 996. Let's say the value of k is 4. And then this minus that. Somebody could have said something else that, hey, let's put the first number as, x, and then the next number as x plus k, and then again the next number as x, and then again x plus k, and then again x. So just alternate. All of these solutions, if you look at them, are perfectly correct. Because in all of these solutions, if you pick any adjacent pair, the difference is no more than k, right? We are talking about absolute differences. Now you can relate it to what I said. So there can be multiple approaches. Each of these approaches could lead to different solutions, and all those solutions are accepted. You just have to pick one approach and you have to prove it that this approach is correct. And then coding it is a piece of cake. So that is the basic idea about constructive algorithms. Does it make sense? How many of you understand it? Now, there is one very important thing about constructive algorithms, and what is it? See, unlike the category of problems like dynamic programming, graphs, binary search, and all, in these category, there is a fixed pattern. There is a fixed way of solving question. I mean, if a question is of DP, you kind of first start with recursion and then you memoize and then you go on and on and on, right? In case of graphs, you try to see that, hey, whether I'll have to use DFS or BFS or, Dijkstra's or what. Similarly, in binary search, you try to see that, hey, what is the separating condition? So there is a fixed pattern. But in case of things like constructive algorithm, there is no fixed pattern. There is no fixed pattern, and that is something which makes it hard, right? So here, every intuition that you would come up with, every intuition would be unique, would be different. So it is the best category of problems for honing your intuitive abilities. See, if you just want to do 100 questions, blind 75, this and that, you can do it at any time. But if you are truly interested in doing the right work, which is to improve your intuitive capabilities, you can go to Code Forces, put a filter of constructive algorithms, and start solving some questions. This is the best way, I would say. Because here, these problems are ad hoc. There is no fixed way of solving it. I mean, you have to come up with something, and every question would demand something different, something out of the league. Okay, great. So what we'll do is, this much is enough of an introduction. We will quickly get started with some problems. And as we solve those questions, you will see that it will start to make a lot of sense to you. Okay, so what is our first question? Let's pick something like this. You are given an integer n, okay? And what we want to do is we want to construct a string of size n. We want to construct a string of size n, so it will have n characters. But the important thing is those characters should only be either A or B or C. This is the important thing. So you cannot use any character other than A, B, and C. And now the requirement is that there should be no palindromic substring of size 3. I should not have even a single palindromic substring whose size is 3. This is the first requirement. And second requirement is I want to use character C as less as possible. So let's say I have got allergy from this character for some reason. So I want to use this character C as less as possible. So these are the two requirements. So you can probably take a quick example. Okay, but before taking example, is this first criteria clear? Do you understand what this criteria is asking for? Does everyone know what is a palindrome? Palindrome is something which reads the same thing from front as well as back. For example, ABA is a palindrome, right? And we are interested only in the palindromes of size 3. Okay. So what we want is that whatever string you construct, in that string, there should be no substring of size 3, which is a palindrome. Okay. So let's say the value of n was 5. Okay. And you wanted to construct a string that contains A, B, and C. And let us say you ended up constructing something like A, B, C, B, B. So should it be considered a valid string? Does it obey all the rules? Does it obey the first rule? Yes, it contains only A, B, and C as characters, but it doesn't obey second rule because here, if you take a look, this particular substring of size 3 is a palindrome, and we did not want that. Okay, so that is the problem with this particular response. So this is not a valid response. All right. Cool. So now one more thing, substring has to be contiguous. Substring has to be contiguous. So if let's say somebody says that, hey, B is also a substring, no, it's a subset, it's not a substring. So when I say substring, it's a string inside a string. So naturally it has to be contiguous. I don't need to say that. I mean, naturally it is contiguous. Okay, can somebody give me a correct output for n equals to 5? Can you quickly throw away a string? Just quickly throw away a string which obeys all these three things. C should be least used than other chars. I mean, C should be used as less as possible. That is the requirement. So you figure out how much of C you want to use. I mean, as less as possible. That's the thing. Okay, so some of you are giving a response. I mean, it's a matching response from everyone's side. That's great. So it is A, B, C, A, B. I think this is totally all right because in this thing, I cannot spot any substring of size 3, which is palindrome. But could we have gotten a better solution because we want to use C as less as possible. So could we have gotten a better solution? Think about it. You have used one C over here. And now I'm saying use C as less as possible. So as less as possible means that you can prefer not to use it also. If it is possible to not use it at all, you should do that. Yeah. So how about, yeah, so one of you have written AA, BBA. So let's look at the substrings of size 3. This is the first substring of size 3 and it is not a palindrome. This is the second substring of size 3. It is a palindrome. This is also not a palindrome. Good. So this is a valid answer. So this is one valid answer. Okay. But can we have some other valid answer also? ABAAB. Okay. ABAAB. Is this valid? ABAAB. Do you trust this? No, this is not valid. Why this is not valid? Because if you look at it, this particular thing over here is a palindrome. So it is not valid. Let me cut it. Okay, anyways, but you understand the question now, right? You completely get the question that you are given n could be anything. Let's say n is equals to 6, and you have to generate a string containing characters A, B, C. I mean, basically no character other than A, B, C should be there. This is your character set. You are a child who doesn't know anything other than A, B, C. And you want to create a string containing 6 characters, 1, 2, 3, 4, 5, 6. Okay. And what my interest lies in is that I hate character C, so I want to use it as less as possible. And I want that, every substring of size 3 should be non-palindromic. Okay. So how can we go about it? Any thoughts, any approaches? What comes to your mind? See, in such questions, when you have generated some output, so let's say somebody generated this, and I don't know, somebody might have generated something else also. Uh, okay, maybe we could have replaced all the A's with B's and all the B's with A's. Yes or no? That could have given some different solution. Let's see that. If you do that, if you replace all the A with B and all the B with A, you would get BB, AA, B, right? And here you can see that this is not a palindrome, this is not a palindrome, and this also is not a palindrome. So both the solutions are correct solutions, right? Okay, so Laura, some of you are saying you would use recursion and all. See, the moment you use recursion, the time complexity is going to go boom, right? Because if this is n, and usually the complexity of recursion is exponential. I mean, it's 2 power n or k power n, something like that, right? So if n is very high, your time complexity will be very, very high. So can you think of something? See, I told you, like constructive algorithms are all about, ad hoc thinking. Recursion is a structured thinking. I mean, you know that a lot of questions where there are elements of choice, they are solved using recursion. But recursion is not the right thing to use over here because that will kill your time complexity. Here you have to think ad hoc. Here you have to think greedily if you know what greedy algorithms are. If you do not know, then also that's okay. So you have to think, okay, so Aman is saying something, A, B, A, B, A, each n by 2 time followed by A if n is odd. So yeah, now he's probably trying to think in some proper direction. Let's give it little more direction. See, what I'll do is you can now look at my screen, just focus here. So I'm just trying to teach you how to think through these questions. Okay. See, uh, if you consider any palindromic string of size 3, how does it look like? It looks like X, Y, X. The important thing is that the first and the last character should be same. What you have in middle doesn't matter. You could have had XZX also. You could have had XQX also. The only thing is that the first and the last character, they should be the same. That's it. Now, if I show you some windows of size 3, what are the windows of size 3 or what are the substrings of size 3? This is the first substring, which is of size 3. So what I would want is, I would want this and this to be different. Okay. Now let's look at another window. Yeah, this is the second window. When I look at second window, what I would want is that this character, the first character and the last character should be different. So I would want this and this to be different. Now, when I look at the other window, what is my next window? It is this. So while looking at this window, I would say I would want this and this character to be different. So that means I would want, I would want this and this to differ. Similarly, when I look at my next window, which is this, in this, I would want this and this to differ. So I would basically want this and this to be different. Now, do you see an important thing over here? The important thing over here is I would just want that the alternating characters are different. This and this should be different. This and this should be different. And you can ensure that very, very easily. How can you ensure that very, very easily? You can just say that, hey, all that I'll do is here I'll put A, and then here I'll put B, and then here I'll put A again in an alternating manner. Now, the same thing is required to be done at these positions also. At these positions also, right? That here you could put just any character and just make sure that whatever you put over here is different, and then whatever you put over here is different. So maybe you can put A over here, and then B over here, and then another A over here. So see, what you have ensured is that any window that you consider, in that the first and last character will not be same, right? Any window, the first and last character will never be same. And if you have ensured that, that simply means that you will not end up getting any substring of size 3, which is palindrome. Does that make sense? How many of you understand what we have done here, right? And see, whatever, the most important thing is that it's not a random approach. See, try to understand this thing. A lot of the times people come up with approaches randomly, and it gets accepted and they feel happy about it. The important thing is to prove it, that why it is correct. It's very important to prove it. So I told you that whatever approach you came up with, you should have a very strong idea behind that, that yeah, this is the reason why it is correct, this is the reason why it is wrong. So in this case, I mean, it was pretty simple. Just to reiterate it, what you had was a string containing some characters, and what you wanted was that every substring which is of size 3, that should not be palindrome, right? This should not be palindrome. This should not be palindrome. This should not be palindrome. Anything is palindrome if, I mean, a 3 size string is palindrome if the first and last characters are matching. So if I make sure that these guys do not match. Similarly, in this window, if I make sure that these guys do not match. And in this window, if I make sure that these guys do not match. So what are you able to see? That these alternating positions should have alternating characters, because the moment you put alternating characters, let's say you put an A, and then you put B, and then again you put A, and then again you put B. That means this window is sorted. I mean, it is never going to be palindrome. This window is sorted. It is never going to be palindrome. This window is sorted. It is never going to be palindrome. And the same thing you can do at these positions also. Just alternate with A, B, A. So now you can say that, hey, this window is sorted. It's not going to be a palindrome. And similarly, you can go ahead and say that this window is also sorted. The other one, which starts from B, BAA, right? So that's the idea. That's the simple idea, that you consider the alternating indices, put A, B, A, B, A, B, and then another set of alternating. So first you consider indices 0, 2, 4, 6, so on and on. And then you consider indices 1, 3, 5, 7, so on and on. And just alternate with A, B, A, B, A, B, A, B, A, B, A, B, and whatever you get will be right answer. Is that making sense? How many of you understand why this solution is correct solution? Not the solution itself, but why the solution is correct solution. Okay, so that is what is important. Okay, see, that is the thing with constructive algorithms, that you have to have some, attention to detail. That is the first thing. And second thing, I mean, like you'll have to pay close attention to every minute detail, then only you'll be able to understand, right? Okay. So let's forget about this question for a while. Let's switch to the second question. That will also be of the same pedigree. If you understand this, you can always go back to the previous one and you'll be able to relate all the threads that I have said. Okay. So let me talk about that question. Let me just explain it first. Okay. In this question, you are given some integers. Okay. So let's say your first integer is n and second integer is m. Now, what does the question say? So question says that there is an expression s of x. S of x is basically sum of digits in x. S of x is sum of digits in x. So what will be the value of s of 95? It will be 9 plus 5, which is 14. I hope you understand that, right? Okay. Now, what we have to do is, given two integers n and m, we basically have to find two positive integers. So find two positive integers a comma b such that s of a is greater than equal to n. It might look mathematically daunting, but it is not. Trust me on that. So have some patience and you will be able to relate. Okay, I'll explain every line in extreme detail, but you have to pay a lot of attention, lot of close attention. Okay. And we want s of b also to be greater than equal to n. But we want s of a plus b to be smaller than equal to m. This is what we want. Okay. So you can read the question for a while, try to make yourself a bit comfortable. So in this case, let's say somebody gave you n equals to 5, m equals to 6. Okay, n equals to 5, m equals to 6. And what we want is, no, sum is not given. You are just given n and m. And now you have to pick two integers a and b such that sum of the digits of a is greater than equal to 5 and sum of the digits of b is also greater than equal to 5. You can see, right? But sum of the digits of a plus b has to be smaller than equal to m, which is 6. This is the requirement. So can you just come up with some maybe output of a comma b? Okay, so let's try with 16 comma 17. So what is s of 16? If you compute s of 16, how much it is? It is 7 and it is indeed greater than equal to 5. And what is s of 17? It is 8 and it is also greater than equal to 5. And what is s of 16 plus 17? 16 plus 17 is 33 and sum of digits here is 6, which is smaller than equal to 6, right? Yeah, so 16 comma 17 is definitely a valid pair of a comma b. But can you have some other solution also? You will see, if you try out, you will see there would be multiple solutions for this case, right? I mean, um, how about something like 6 comma 7? Let's say you just have 6 comma 7. What is s of 6? S of 6 is 6, which is greater than equal to 5. S of 7 is 7, which is also greater than equal to 5. Now, S of 13 is equal to 4, which is, you can see, this thing is smaller than equal to the value 6, right? So 6 comma 7 also sounds like the right answer. Okay, cool. Now there is one important thing in this question. I'll tell you what that important thing is, that the value n and m which are given to you, they are lying in between 1 to something, maybe let's say 1129. It's a random value. The source of this question is Codeforces. I'll share that link in some time. So n and m are lying in this range. And now we have to kind of solve this question. So yeah, how can we just go about it? Is the problem statement clear to everyone? It's a little longer one, so I'm just reconfirming. Does it make sense what we are supposed to do? These things are just dramatic, okay? Okay, just read through it. Just read through it. See, it's just a sequence of statements. You understand what is S of A? It is sum of digits in A. What is S of B? It is sum of digits in B. What is S of A plus B? Whatever is the result of A plus B, that will be a number. In that number, whatever is the sum of digits, that is denoted by this. Now you are given n and m, and you have to come up with A comma B, which obeys this rule, that sum of digits of A should be greater than equal to n, sum of digits of B should be greater than equal to n, and sum of digits of A plus B should be smaller than equal to m. Like you had an example, n was 5, m was 6, right? Somebody said that 16 comma 17 is a valid pair. And that's true, because if you consider s of 16, the sum of digits is 7, and that is greater than equal to n. Here the sum of digits is 8, and that is also greater than equal to n. And when you consider s of a plus b, that is s of 33. And what will be s of 33? 6. And that is smaller than equal to 6. That is perfectly all right, right? So the faster you understand these set of statements, the more sense it will make. Okay. So I'll just head down and probably write that again. S of A should be greater than equal to n. S of B should be greater than equal to m. And S of A plus B should be smaller than equal to, sorry, should be, this is also n, should be smaller than equal to m. And now this is an important constraint which is kind of thrown at you. M is greater than n? No. M and n are independent. You could have a value of m which is 2, and you could have a value of n which is maybe 7. That's totally possible. So this question is assuming the fact that for every pair of n comma m, there exists at least one solution. This is what this question is assuming, yes or no? Because if it exists, that is the reason it is asking you to print one such solution, right? And now, okay, so Harshit has a point. He's saying force followed by 5, and then another force followed by 5. That's a very interesting point. We'll take a look at that. But can I say one thing? See, the key thing over here to look is, what can be the smallest value of m? Just read this constraint and tell me what can be the smallest value of m. The smallest value of m can be 1. Now, if a plus b, the value a plus b that I am getting, if s of a plus b is 1, then I am always taken care of regardless of what my m is. Do you understand the point? So I know for sure that my m will always be greater than equal to 1. So m could either be 1, or it could be 2, or it could be 3. If I somehow ensure that the sum of the digits of a plus b is always equal to 1, then I'll always be taken care of, right? Now tell me, what kind of number will have sum of digits as 1? Which kind of number will have sum of digits as 1? Very good. So that's the first thing to click in the brain. So see where from I started. I started from the fact that the smallest value of m can be 1. If the smallest value of m can be 1, now what I want is that this sum of digits should be smaller than equal to 1. Smaller than equal to m, right? So if this thing is 1, it will always be smaller than equal to m. Why? Because m is always greater than equal to 1, right? Okay. Now, that means if a plus b is of format 1 followed by 0, 0, 0, 0, 0, then I'll always be taken care of. Always be taken care of. Okay, now let's say you have a value A, right? This value A should be created in a way that sum of digits here should be greater than equal to n. Let us say the value of n for now is could be anything. Let's say 29, right? For a moment, if I try creating a number A with all the digits 9, all the digits 9, then what is the least number of nines that you would want? What is the least number of nines that you would want so that S of A is greater than equal to 29? Four nines, very good. So if you have 9999, you are 100% sure that this thing, and you can generate it very easily, right? 29 divided by 9 is 3, and then there is one remainder. So I can create A with four nines, and I'm 100% sure that 9 plus 9 plus 9 plus 9 is greater than this. So A is taken care of. A is taken care of. Now I have to take care of B. While taking care of B, I have to make sure that A plus B is smaller than equal to M, and not just smaller than equal to M, A plus B, S of A plus B is equal to 1. Basically, A plus B should be of this format. This is what I have to ensure. So can you tell me what kind of B I should pick? What kind of B I should pick so that my job is done? A lot of you are saying pick B as 1. Okay, so you are tempted to say that. Why you are tempted to say that? Because the moment I pick 1, this plus this will give me 10,000, and S of 10,000 is 1. So this thing is taken care of. But is this thing taken care of, guys? No, exactly. This is not taken care of. That's the point. So think, I mean, you have thought very well. You just have to augment your thinking. You thought it so well that, hey, if I put 1 here, everything will become 0. Only 1 will come and I'll get this thing, and S of this will be 1. But just augment your thinking and probably add something to your thinking so that you can take care of this condition. So I would say that if sum of these digits is greater than equal to 29, then if I have any number which is 9999 followed by anything, the sum of digits of this also will be greater than equal to 29. Can I say that? Yes or no? Right? Because four nines are having a sum of 36. So if I have a B which is four nines followed by something, 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 something random, that would also have a sum which is greater than 29. Now a lot of things should ring in your head. What exactly? You would say that, hey, my A that I chose was 9999. Now let us choose a B where the last digit should be 1, and just make these things as 000 for now. And then just do one thing, put four nines ahead of this. Why you have put four nines ahead of this? To make sure that it is in this format. It is 100% guaranteed that this will have a sum of digits, which is going to be greater than equal to 29. And at the same time, if you take the sum, 9 plus 1 is 10, 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 it is of this format. So what I have done is, you said that let B be 1. I stuck to it. I said let the last digit be 1. But in order to honor this criteria, I had to bring in these many things at the front and put zeros after that. Did you understand it? How many of you understood the idea behind it? So do you notice how small attention to detail are used to prove whatever we are doing is right or wrong? Okay, so I can reiterate it with another example. See, if you did not understand in the first go, you will definitely understand in the second go. More attention to detail. Just pour more attention to detail. See, these things are not usually taught by anyone. Why? Because it's very hard to pay attention to these things and kind of understand, but these are the gems of algorithms. These are the things that add true value. Okay. So okay. let's take an example where your n is equals to, what do you want to take? Let's say 25. All right. And your m is equal to anything, right? M is equals to, let's say, 11. What I want to find a and b such that s of a. So let's first look at it, okay? And then, it'll make a lot of sense to you. Then you can probably ask the right questions. I want that s of a should be what? Greater than equal to 25. S of b also should be greater than equal to 25. And s of a plus b should be smaller than equal to m, which is 11. Now I told you one thing, you saw it in the constraint that the smallest value of m can be 1. So if this thing is 1, then I am sorted, right? Because you want smaller than equal to 11. So if this is 1, 1 is always smaller than equal to 11, right? It could have been 12. It could have been 13. It could have been 100. It could have been anything. I do not care, right? I want that s of a plus b should be 1. And for this to be 1, it should be in this format, 1 followed by some zeros. 1 followed by some zeros. And now this gives me one sharp intuition that, hey, this kind of number can be generated if you add 1 to a number of this format, 99999. If you add 1 to it, this kind of number is generated. So that pushed me to think that, hey, why don't I create my A, which is made up of nines? Made up of nines. It is very easy to create because I want that the sum of digits should be greater than equal to 25. So how many nines do I need? Can you tell me the minimum number of nines that I need so that, yeah, 3 nines. Very good. So if my A is 999, my job is done. And I can do that pretty easily. I can just divide this 25 by 9, okay? And 25 by 9 and take a seal of it. So there will be 3 nines. So you can create an A which is composed of 3 nines, right? Now, you have taken care of this property for A, but you also have to take care of this property for B. And for A plus B, all of us agreed that if the number is in this format, 1 followed by some zeros, we are sorted. So some of you were tempted to say कि B को 1 ले लो. You said that pick B as 1. Because if you pick B as 1, A plus B will be 1000. And here the sum of digits is 1. So this thing is taken care of. But you forgot about taking care of this condition, S of B. In order to take care of this condition, I told you that, hey, if we bring these digits here also, then we will be done. So I said that, hey, let's bring them on. Let's bring them on at the beginning. Now, to make sure that your result is of this format, 1 followed by zeros, let's put some zeros in between. So with that, what will happen? Just try adding this in this. See what happens. 9 plus 1 is 10, 0. 9 plus 1 is 10, 0. 10, 0, 0, 0, 0, 0, 1. Why I have padded these things at the beginning is to take care of this condition. Because if the sum of these digits is greater than equal to n, the sum of these digits plus some extra digits will also be greater than equal to n. And these two numbers are such that their addition is always of format 1 followed by zeros. So s of a plus b will always be 1, which will always be smaller than equal to n. Does it make sense? How many of you now truly understand how this solution is built? So this is the mode of thinking which has to be put in case of constructive algorithms. And that's why, the best of the folks who are really good at algorithmic thinking, problem solving, are the ones who have really solved a lot of problems on constructive algorithms. I encourage a lot of people to do that. So you can do that if just in case you would want to try that out. Okay. We can also look at the code of it. Okay. So just one more thing. You don't know how large your n and m could be. No, you know it. I mean, n and m are not very large. They're very small. So you can create these numbers as a vector of, integer or vector of character also. So what I mean by that is that if you know that you need 3 times 9, You can just create a vector which contains 3 times 9 while you are constructing. It will be easier to construct uh, a vector containing digits rather than an integer looking 999. Okay, when you code, it will be easier to do that. Do you want to see the code for this? So let's see what we have done. So I told you I'll create a vector of characters to store, all nines. And if you look at this while loop, it will make a lot of sense to you. Does it? Do you understand what we are doing in this while loop? We are just, generating the first number. We are generating the first number. While generating the first number, we are just composing it of nines. So there is a sum variable which is 0, and we are always doing sum plus equals to 9, sum plus equals to 9 till the sum is smaller than n, right? So imagine if the value of n was 29, you'd have placed 9, then again 9, then again 9, and then again 9. So 4 times 9, it would have got pushed over here, right? And now you're creating the second thing, which is your B. How you're creating your B? First, you're pushing 1, which is the last digit. And then if let's say there were 4 nines over here, how many zeros you want to push? There's a question from you. How many zeros you want? 3 zeros, right? 3 zeros. That the last digit is 1 and then it's followed by 3 zeros. So the loop has run from 0 till n minus 1, where s1 dot size minus 1. So we have pushed these many zeros, and then we have pushed as many nines as we pushed over here. So whatever is the size of this vector, those many nines we have pushed again. And now because we are pushing, so the digits have got pushed in reverse order. So we have printed them in just the reverse order, and then the job is done. That's it, as simple as that. Okay, how many of you understand the code? Okay, whether you want to code this thing in Java or Python, you can do it pretty easily. It's not hard to do it. It's very, very simple to do it. Okay, so because it doesn't use any library functions or collections or STL. Okay, I'll do one thing. I'll just copy the code and put it here in the chat box. But please do not just look at my code. That is not the purpose of me sharing this code. I'm just sharing this for your own peace of mind. First code on your own and then only look at it. Do you need the code for first question also? Okay. Ah, let's see. You remember the solution of first question, right? Right. Okay. So what do we do here? Okay, so it was a simple one where I told you that first we will iterate on the even indices. So even indices are 0, 2, 4, 6. So you can see we started from 0 and we are doing I plus equals to 2. So we'll go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. And you can see the logic. Current is A and we are toggling from A to B and B to A, right? So we are doing array of I equals to current, and then we are doing current plus plus. So current plus plus means from A it will become B. So at index 2 you will be putting B. And then if you see that current is B, you toggle it back to A. So that is what you are doing. So in this particular loop, you're just, kind of putting A, B, A, B, A, B at indices 0, 2, 4, 6. And here you're doing the same thing, but at the odd indices, which is index 1, index 3, index 5, index 7. And because I chose to use a character array, in character array, the last thing should be ideally null for it to be printed using cout. So I did that. Is it making sense? How many of you now understand this code also? Yeah, simple enough. See, I want to tell you one thing. Constructive algorithms, coding, even a kid can do. Coding is not the main thing. What is the main thing? So what have you learned? Tell me, what is the most grueling thing when it comes to solving constructive algorithms problem? It's the solution and the proof behind everything that you do. Because anything that you do could be wrong. Could be wrong. So you have to have a lot of attention to detail to find out why it is wrong or why it is right. Okay, the day you learn how to do those things, you will take a quantum leap in your problem solving skills, I tell you. Much more than solving some sheet of problems. That is guaranteed. So there is a 4x4 grid. Okay, something like this. You can look at my screen instead of reading the question. It will make much more sense. There is a 4x4 grid like that. Is it a 4x4? Yeah, it is. And now we have got some tiles. The dimension of our tiles are either 2x1 or 1x2. So our tile is either of this form, 2x1, or it is of this form, 1x2. Okay. Now you have been given a string. So it says you have been given a string. Uh, it's a string of zeros and ones. So let's say you have been given 0, 1, 0. So 0 means vertical tile and 1 means horizontal tile. So you can say this is a vertical tile and this is a horizontal tile. Now what you have to do is, whenever you see 0, you have to put a vertical tile somewhere on this grid. You have to put a vertical tile somewhere on this grid, right? So for example, you saw that it is 0 and now you have to put a vertical tile. So what you will do is you will take it and probably you will put it over here. So this area would be shaded because it is covered with this thing. The important thing here is whenever you are putting the tiles, the two tiles should not overlap. Overlap must not happen. So what I mean by that is, let's say if this is your first tile that you have put like this, the second tile should not touch this and this. Okay, that's important thing. So now the next character is one, which is horizontal. So it means now you have to put a horizontal tile. Okay, so there are multiple ways you can put a horizontal tile. You could probably pick a horizontal tile and you can just place it over here like that, right? And then again you have 0, which is vertical. So again you pick a vertical tile and you can put it anywhere. So let's say you put it here. So this is basically how you have put, and this string could have been larger. This string could have been larger. Maybe the next character again was 0. Now there is one important rule in this question. The rule in this question is that if there is any row which is completely filled, then all those shaded areas are destroyed. So what it basically means is, like in this case, you can see that this first row is completely filled. So now it will be destroyed. So it will be made empty. So it will now become something like this, where only this part and this part is shaded. So what it means is that if my next character is 0, which means a vertical tile, so I can put that vertical tile somewhere. So there are multiple ways, right? I can probably just take that and take a vertical tile and probably put it here. And I could also put it here. Of course, I can't put it here because if you tried putting it here, this area would be shaded again. So the basic thing is that you have to scan the characters of this string sequentially. And if you see a 0, you have to pick a vertical tile and put somewhere. If you see 1, you have to pick a horizontal tile and put somewhere. You have to put in a way that there are no overlaps. Okay. An important thing to keep in mind is that if any row or any column is completely filled, then I mean, it's like a game, if that row is completely filled, then that is freed. If a column is completely filled, that also is freed. So that is how it is. Okay. So you can consider a random simulation of it. You can say that, let's say you have a 4x4 thing like this. And then you have a string where 1, 0, 1, 0, 0, 1, 0, something like this. Okay. So let's say you have 1. It means you have to pick a horizontal one. So you will pick a horizontal tile and probably you can put it here. So when you put it here, this is shaded. Now you have a vertical tile. Now tell me, can you put this vertical tile over here at this cell? No. Can you put it here at this cell? No. Why? Because overlap should not happen. But can I put it here? Yes. Can I put it here? Yes. Can I put it here? So let's say I choose to put it here. So now this is gone. The next one again is vertical. Because it is vertical, can I put it here? Yes. Now see, what will happen is, because this first row is completely occupied, so it will be freed. So it will be freed. And now the state of your grid will be something like this. All right. Now you get a 0. 0 means horizontal again, right? Because it is horizontal. Sorry, 0 means vertical. 0 was for vertical, right? This 0 vertical again. So probably you can pick this thing and put a tile over here, right? You get a 0 again. So you can pick this thing and put a tile over here. Now what will happen if you take a look, this particular row, it has become completely, filled. So in the next iteration of the game, this will be freed. So when this will be freed, it will start looking like that. Only this and this will be occupied. Everything else is freed. So, basically what you have to do is you have to make, I mean, every character that you read, for that character, you have to tell uh, the top left corner of the submatrix where you placed your tile. I mean, for example, if let's say this is the next thing that you get, and this is vertical, and if let's say you decide to place it over here, then you have to output the coordinates of this index, right? Similarly, now let's say this is 1. This is 1, it means horizontal. And if you decide to put it over here, so put it, but then output the index of this cell, right? And now let's say this is 0, it is again vertical. You may decide to put it over here. So put it and then output the index of this particular cell. So you can just keep doing that, and you just have to keep outputting the, the index of the cell where that tile is being actually placed, right? Now there can be multiple ways of placing them. So you just have to output one such way. Does it make sense? Does this game make sense that how it is being played? Yes or no? So see, there is one important thing to understand. Okay, one of you said if we get a 0, put the vertical one in top half. If we get a 1, put it in the lower half, side by side. Okay, all right. Graph coloring, not needed. That's not really needed. See, that's the thing with constructive algorithm problem. It doesn't require you to know fancy things like DP graph, segment trees, even maybe recursion is fundamental thing everybody should know, but it doesn't require you to know fancy thing. It just requires you to have a lot of attention to detail and reasoning abilities, as simple as that. Okay. When people talk about problem solving abilities, this is the true problem solving ability. The true problem solving ability is not knowing the approach for LCS or the approach for DFS. Okay. So let's do one thing. Let me show you something interesting. Let's say there is a grid like that. Okay. 4x4 grid. Now you had a string and the first character was a 0. The first character was a 0. What you can choose to do is you can pick this particular thing and you can put your first vertical tile over here. Now let's say the next character is 1. If the next character is 1, what would be the best move that you would want to make? 1 means that you have to pick a horizontal tile. You have to pick a horizontal tile. So where would you want to ideally put this horizontal tile? So some of you are saying, put it in the bottom right, put it in the bottom right place. Maybe this. How many of you want to put it here? Just type in yes or no. See, uh, it's totally, or it's correct to put it over here. But what I want to tell you is, if I want, I can put it over here also. So let's say I go ahead and put it here. Now see why I am putting it here or here. Why I'm interested in this place, I'll tell you. I'm interested in this because if the next character comes out to be something, how many choices do you have for next character? It can either be 0 or it can be 1, right? If it is 0, that means now you have to pick a vertical tile. That vertical tile, where will you put? Would you immediately want to put it over here? Yes or no? Of course you would want to put it over here. Because you know the moment you put it over here, this column is filled. So now this column will be freed in the next round. You understand my point? Similarly, if your next character, instead of being 0, it was 1, that means you'd have been required to pick this thing. Now picking this thing, you would have been tempted to put it over here, because the moment you put it over here, this entire row would be filled and then this entire row would be freed. So in reality, what is happening is, if I fix one simple rule that, hey, my rule says something like this. You see, now the real story begins. My rule says that if I get a vertical one, I'll put it here. And if I get a horizontal one, I'll put it here. That is my idea. Okay. Now, when this has happened, let's say I first put my vertical one here. So this is shaded. And then I put my horizontal one over here. This is shaded. Now, so you had a vertical, horizontal. Now, if the next thing is vertical, you would want to put it over here. You would want to put it over here so that this thing is freed. And if the next thing is horizontal, you would want to put it over here so that this thing is freed. Okay. Okay, why making it free is important? If you make it free, you go back to the original state of the game. The original state of the game is where, just imagine, uh, let's talk about it here. You have a board where there are 0 verticals. Oh, let me not write like that. Where there are 0 verticals and 0 horizontals. Okay, 0 vertical tile and 0 horizontal tile. Now you have been given a string. Okay, let's understand it step by step. So I'll be drawing it over here and reasoning it over here. Okay, so what can be your first character? How many choices do you have for first character? Tell me that. Your first character could either be a 0 or it could be a 1. I mean, let's not talk in terms of 0 and 1. Let's talk in terms of vertical and horizontal. That's just for it could either be a vertical or it could be a horizontal. If it is a vertical, you would be putting your tile over here, right? So in that case, you would move on to a next state where you would say, I have one vertical tile, of course, located here, and 0 horizontal tile. If this thing was horizontal, you would have placed your horizontal tile over here, over here. And then you would say that, hey, I have moved to a state where I have one horizontal tile and 0 vertical tile, right? Okay, now what can be the, so let's say you came from here to here. Coming from here to here means that this is your state right now. This is your state. Okay. Now, what can be the possibilities for next character? Your next character again could either be a vertical or a horizontal. Okay. If your next character is vertical, that means you would pick a vertical tile and you would immediately want to put it over here. Because if you put it over here, what is going to happen? You are going to get back to the original state. Why get back to the original state? Because the moment you put it over here, this is filled. And if this is filled, it means that this is now going to be freed. It is going to be completely freed. If it is going to be freed, I'll get back to the original state of having 0 verticals and 0 horizontals, which is an empty board. Is it making sense? How many of you get this point? Right? Similarly, if you look at this particular case, what was this case where, let's erase these things. So this was the case where you had put your tile over here at this particular place, right? Now, if let's say after this, the next character was horizontal, that horizontal tile, you would want to latch onto it and you would want to immediately put it over here. Because the moment you put it over here, you know that this row will be filled and it will completely be destroyed and you will basically go back to the original state, right? You understand this point? Okay, now let's talk about the other case. What is the other case? That if here, when you had, let's draw this thing here. 1, 2, 3. So when you had one vertical tile placed over here at this location, after this, if you got a horizontal tile, so after vertical, if you got a horizontal tile, in that case, what you would want to do? In that case, we are saying we would want to put our next tile over here at this position. So I would move to this state. So what is this state? This is the state where you have one vertical and one horizontal. Vertical is at 0, 0 and not 0, 0. This is 1, 1. And this is, what is this? This is 3, 3. 3, 1, 3, 2, 3, 3. Right? So you would move from this state to the state where you have one vertical and one horizontal. Similarly, if you talk about this situation, what was this situation corresponding to? This situation was corresponding to the case where you had a matrix and you had decided to put one horizontal and that horizontal one was put over here. Now, after horizontal, if your next character is vertical, you would want to place over here. And if you're placing it over here, it's the same state that you are going to get at. It's the exact same state which you are going to get at. I should have marked these arrows ideally, but I hope you understand what we are doing. Okay, now when you talk about this state, 1, 1, which is this, at this point of time, if you get a horizontal one, let's say if your next character is horizontal, you would pick a horizontal tile and would you not want to put it here? I am 100% sure you would want to put it over here, right? Because the moment you put it over here, what would happen? This thing would go away, this thing would go away, and you would get back to this state, right? And if you have a vertical one, then you would have put it over here and you would have gone back to that state. So this is a state diagram. This is a free-flowing state diagram of my strategy, where I can say that I can start from here, and if what I get is vertical, I do this. If what I get is horizontal, I do this. At vertical, if I get another vertical, I go back to that. At vertical, if I get horizontal, I get this. At horizontal, if I get vertical, I go to this. At this state, if I get vertical, I go to this. So do you see that it's an infinite state diagram? And it will make sure that the game is always concluded regardless of what set of characters you have. I mean, for any set of characters of VH, for any combination of VH, there is a valid transition of states that is possible. How many of you understand this idea? Even 10, 20, 50% of it. How many of you get it? Just type in yes or no. How many of you completely get it? If you got it completely, you can type in complete. Kind of completely got it. Isn't it beautiful? I mean, if you really understood how beautiful it kind of sounds, right? So this is the thing about it. I mean, I have completely reasoned it that by putting vertical tile here and horizontal tile here and following this state transition, I can always get my job done, regardless of anything and everything. The only important thing to understand is, so let's say, I mean, if you got a horizontal tile, and if you already know that there is a horizontal tile that is present, in that case, you would want to put a horizontal tile here, and that way you would want to get back to the state of having one vertical and zero horizontal. So you basically have just to track that on your board at any instant of time, is there a vertical tile? Is there a horizontal tile? Or are there both of them? So either it will be 0, 0, or it will be 0, 1, or it will be 1, 0, or it will be 1, 1. 0, 0 is this state, 1, 0 is this, 0, 1 is this, and 1, 1 is this. So if you know whether you have a vertical tile or a horizontal tile or both or none of them, you can perform your transitions, right? And mind it, this cell was 1, comma 1, this cell was 3, comma 3. So if you start with an empty board, and if your first character is, let's say, vertical, where do you put? You put here. But if first character is horizontal, where do you put? You put here. And now, what move you make for your next character depends upon, if you have horizontals or verticals right now. So let's say your next character is also horizontal, and previous one was also horizontal. So you know that you have one horizontal, zero vertical, and you got a horizontal right now. So now you would want to put the next horizontal right over here, okay? And go back to the original state of having zero vertical and zero horizontal. So this is how you'll have to kind of try to code it, and you'll be done. Let me show you the code. Okay. Um, all right. So see, I am tracking how many verticals and horizontals I have. So let's say vertical is 0, horizontal is 0 initially. And then if S of I is 0, S of I is 0 means vertical. So now I'm tracking, do I have a vertical one? Do I have a vertical do I have a vertical tile on my board? If I have a vertical tile on my board, that must have been at 1, comma 1. So it starts from 1, comma 1 and goes till 2, comma 1. So in that case, if I get the next one as vertical, I would want to put it at 3, comma 1 so that the first column gets filled and I go back to the original state, right? But you know, if the number of vertical is 0, in that case, I would want to put at 1, comma 1. So that's the idea. So if there is already one vertical tile, the next vertical tile I want to put below it. And if there are no vertical tiles, I want to put the first vertical tile at the top. And I always toggle the number of verticals, because if it's the first vertical tile that I'm putting, then I have one vertical. And if there are two of those, it becomes 0 because both of them are coming in the same column and they are being removed. So this is how I'm toggling the number of vertical. So vertical equals to 1 minus vertical. So if you already have one vertical, you put 1 below it, it becomes 0. And if you have none, you have just put 1, right? The same and opposite logic is written for horizontal. So if your S of I is 1, that means you got a horizontal one. Now, if you have got a horizontal one and there is already a horizontal tile, so if there is already a horizontal tile at 3, comma 3, you'd want to put the next at 3, comma 1 so that this entire third row vanishes. Okay. And if the horizontal tile was not there, then it's the first horizontal tile that you're putting. So you'd want to put it at 3, comma 3. And then you would toggle. Why to toggle? To toggle. See, if there is already, let's say you have V, comma V, vertical and then again vertical. The first vertical tile that you get, you put it at 1, comma 1. So it is at 1, comma 1 and 2, comma 1, right? If the next thing is also vertical, you put it at 3, comma 1. That is what you do, right? Vertical ke under vertical, right? You put it at 3, comma 1. If you do that, what happens? The vertical tiles vanish because that column 1, it vanishes. So then you change your vertical to 1 minus vertical, which becomes 0. So if you look at it, it is a state of 0, comma 0, which goes either to 1, comma 0 or 0, comma 1, then 1, comma 1, and then it floats. So this, whatever I have written over here is just code of the state diagram that I just showed you. Okay, what if we keep putting VT at 0, 0, 0, 1? Okay, see, you can try doing that and you will see you will be in trouble. Why? Because it may happen that for the next character that you have, which is vertical or horizontal, there are no spaces left. It can happen. And you can easily think of a test case like that. And I'll strongly recommend you to try thinking of a test case like that. Okay. Yeah, all those approaches where you are thinking that you will do a brute force, which is you will check that if the next space is left, let's put it there, they will lead to issues. Why? Because they are not ensuring that there is space left for the next character, because your next character could be vertical, horizontal, anything. In this approach, the beauty of this approach is that every time I have at max two tiles. First tile is like this and second tile is like that. Every time. Okay. So when the next tile comes, I either place it here and get rid of this row, or I place it here and get rid of this column, depending upon whether it is horizontal or vertical. So regardless of what my string is, this game can always be played. The beauty was that if a row or column is filled, it is destroyed. So you get back to the original state, and then the same thing can continue.